So, guys, all right. I'm going to shortcut this a little bit. But the kinds of things I need you to be able to identify. Tangent is sine over cosine. Cosine is 0 at the odd halves of pi. So that's where tangent is going to have asymptotes. N can be a positive or a negative whole number. Cotangent is cosine over sine. And everywhere that sine was 0, cotangent's going to have asymptotes. Tangent's forever going up, it's a happy function. Cotangent is always going down, it's a grumpy function. Oh, sorry, I was asking for asymptotes, so I had it right. These asymptotes, all the whole numbers of pi. Okay, cosecant, I don't really care what it looks like right now, but cosecant's going to have asymptotes the same place that cotangent had asymptotes, all those whole numbers of pi. Why? Because it's 1 over sine. Any time that sine is 0, cosecant's going to be undefined. So hopefully you guys have these in your notes a couple of times now. Because what I want to do today is really just get you practicing trig integrals. It started to click better with third period after this, so we're going to try. Okay. People are still working. I will wait. All right. Still. I have a worksheet for you guys to do in class today, and we're going to do them 3 problems at a time. 3 different groups are going to put up on the boards, 1, 2, and 3, and then other groups are going to do the problem on a specific one of those 3 on the whiteboard, and we're going to check that they're correct in how we're doing the process, okay? So to model what we're doing. Here's my question. I want to find the one and only, oh, hang on, sorry, I need to back up a second. This, lowercase a versus capital A. It's a stupid convention, but arcsine. Sine goes forever. Where's sine negative a half? All of these places. If I ask you lowercase arcsine negative a half, ooh, geez Louise, I'm asking for all of them, all of the infinite answers. Okay, where's sine negative a half? Is sine the y value or the x value? Y value. So I need to find this angle and that angle. Valentina, how am I going to find the reference angle that makes sine 1/2? It's from pi over 3, it's root 3.
So it would be pi over 6.
Pi over 6. So the reference angle is pi over 6. Mache, how do I get that angle?
Just add pi.
Add pi. Ivan, how do I get that angle? It's a full circle. Short by how much?
Minus 1/6
So 6, oops. Multiplying by 6 over 6, 6 over 6. Okay, so that's the two answers that can happen in a circle. I want an infinite number of them. So this answer, Mache gave me that. And if I add a full circle, a whole bunch of times I get all of these. Or if I subtract a full circle, I'm getting all of those. Then, taking Ivan's answer, that gave me this one. If I add a full circle a whole bunch of times, I get those guys. Or if I subtract a full circle, I get these guys. That's an infinite number of answers, lowercase a. Capital A, I very, very specifically only want that little viewfinder. How many places? Yes.
When you say like for the lowercase, would we just give you the equation?
Okay. I'm never gonna ask the lowercase one that requires you to give me an infinite number of answers. I will ask for more than one answer and I'll show you in a specific way when we get to it. But just showing you lowercase a means you need to go on forever. It's 7 pi over 6. It's 11 pi over 6. And then add that twice, so 19 pi over 6 and 23 pi over 6 and oh my god, forever and ever. Capital A says give me the answer just in this little viewfinder. There's only one. How do I get that angle? What quadrants is this closing in? Is it 1 and 2, 2 and 3, 3 and 4, 4 and 1?
1 and 4.
1 and 4. So I'm gonna get the sine, the angle for sine in somewhere in this window, 1 to 4. It's negative, so it's down here. What was the reference angle that Valentina found for us? Pi over 6. So how do I do pi over 6 but go down?
Negative.
Yeah. Okay. Yes, Alana?
Wait, so could negative pi over 6 be an answer for like the lowercase arc sign?
Yeah, it is, because what if n is negative 1? So 11 pi over 6 minus a full pi. So those n's can be negative as well. It could be subtracted.
So is it just the closest value?
Kind of. Okay. So back to this. The process that I'm asking you guys to do for solving these things is first sketch the region where the answer is going to come out of. And we talked about this. It never goes well. I'm kind of just asking you guys to memorize right now. Cosine negative values come from there. All positives come from quadrant 1, but negative cosine values, quadrant 2. Sine and tangent from there. So this, sketch the output region. It's sine, as Alana said a second ago, it's gonna come out of there. It's a negative ratio, so where is sine negative? It's down in this quadrant. So that's this one. Draw the terminal side of the angle. What reference angle makes sine 1/2? Valentina told us pi over 6. And then William's like, oh, wait, to go down, to go that way, it's negative pi over 6. And I'm asking you to draw this green arc so that you don't go that way. It is true that 11 pi over 6 also makes sine a half, negative a half. It's not the answer that I want. I want it from inside the little green force field. All right. Show another example. This time, sine. You know, am I gonna draw this swoop this way, or am I gonna draw this swoop like a sunrise? Sine inverse? Where does it come out of? The right side of this thing. Okay. Sine the y value or the x value?
Are you asking me? What's the question again?
Is sine the y value or the x value?
Oh, the y value.
The y value. Where's the y value? 1? Or like, how would you point the angle to it? So where's the y value? 1, the y value is 1 right there. So the angle is pi over 2. So when they're on the thing, that's when it gets harder. Okay, I want to get you guys started on the practices, but I want to show you cosine at least. Okay. Luca, first thing was I asked you guys to draw the swoop. Is it snow angels or is it sunrise? I don't know. Is it snow angels or is it sunrise? For cosine inverse. The second one? Sophie?
I'm just wondering, like, how do you figure out if it's like this?
Okay, at this point, I'm asking you to just memorize it. This one's cosine inverse. These guys, sine and tangent. That's what I meant by writing this over and over again. Cosine, origin, sine, and tangent. Okay, and then the next thing I asked for you guys to solve this, Oliver, was to draw the stick of the angle in there somewhere. Is the stick gonna be on the blue plus sign in here? Is it gonna be somewhere in quadrant 1 or somewhere in quadrant 2? To find what angle's gonna make cosine negative. In quadrant 2, so it's not on the blue lines, it's not in quadrant 1, but it's in quadrant 2. Okay, now to find the reference angle. Aaron, if you guys notice, I wrote the ratios on the board. Root 2 over 2 is the same thing as 1 over root 2, so that you can look at your triangles and get the reference angles from there. So where is cosine 1 over root 2? What angle? Pi over 4. So the reference angle is pi over 4. But Kylie, I want that angle over there. So how much did we need to move to get there? Okay, a whole half circle is how many in radians? Pi. I didn't get all the way there. I was this much short. Get it a little bit? Okay, so I'm gonna hand out the worksheet. First thing on the worksheet is to draw the triangles and the plus sign again. Why? Because you need to know it.
So it's cosine and then col and then sine and tangent.
Yeah. Emery, thanks for volunteering. Can you label the 2 triangles up here? And Nora, can you label the circle? Radians, please. Nora, hang on. All right, sorry. Okay, sorry. You weren't that far into it. Don't be mad at me. And Eliza, is x the sine value or the cosine value?
Cosine value.
Cosine, alphabetical order. Okay. Do we agree with the triangles? Third period, there was one small thing wrong. So let's make sure, because if you have the triangles drawn and labeled wrong, you're hosed. So pi over 4, pi over 4, 1, 1, root 2. The other class did not remember the square root on the 2. Okay, this one across from pi over 3 is root 3. Pi over 6 is the small one, 1, 2. Yeah, okay. Got those? And really, like I say it every time, across from pi over 3 is root 3. And then hopefully you can put the 1 in the 2. The 1 goes on the smaller one, the 2 goes on the bigger one. Yeah? No one?
Yeah.
Good? Yeah. Yeah. 3 hours of non-math yesterday. I got a lot of grading done. I don't know about you guys. I'm like, whoo! Luca, it's the little things. It's the little things. Okay, so now, wrong thing. So remember, I want you guys to draw which arc our angles come from for each of these. To draw the angles stick into it, so you know it's quadrant 1 or it's quadrant 2 or it's quadrant 3.
Which one's quadrant 3? What's that?
Nobody comes out of quadrant 3, so it's never quadrant 3 when it's restricted like these capital ones are. So, group 1, can you draw yours up there? Group 2 and 3, can you do this problem on the whiteboard? Group 4, can you put yours up on the chalkboard up here? 5, 6, and 7, can you do it on the whiteboard to have verification? And group 8, can you put it on the side chalkboard? And groups 9 and 10, put it on the small whiteboard at your table.
So it's just like.
The small whiteboard?
Okay, so the ones that are circled, I want you up on the board. The ones that are not circled, you guys are gonna write them.
But are we just number?
You got 5 over 6?
Well, you should do all of them,
Yeah.
but the work that I wanna see on the whiteboard is on your particular.
Well,
Supposed to answer one, like, off the whiteboard.
Right, you're supposed to do all 3, but put the work for that specific one
Oh, yeah.
on the
it
whiteboard.
would be negative if it's going this way, and not if it's going, if it's 5 or 6, then wait a minute. You're right, I think you're right.
Okay, do all of them.
So when would you get one of these?
I would do like the,
When it's positive.
thing with like the bars around
I see where the confusion.
Do we like just write like
Okay, so what I see, group one has put up their thing, and they said it's sine inverse. So sine is gonna, it's gonna come from, I'm calling it snowing, quadrants 4 and quadrant 1. It's positive, so the angle's actually gonna be from quadrant 1. And then, looking at the triangles that Emery drew for us, sine is opposite over hypotenuse. Where is opposite 1? Pi over 6. That is my answer. It's over and it's done. So, group 4, you guys are supposed to be putting yours up there. 5, 6, and 7. I wanted to see the work, like a little bit of a picture. So,
We're supposed to do it on speed, but we're just.
so Ivan, what's the picture for cosine inverse? What do you guys have? Cosine. Let's see, okay, there we go. Cosine comes, that's sunrise, it's one of these guys, yes. And it's positive, so. Positive, yep, so they're putting it up. So it comes out of quadrant 1. What reference angle? The angle's wrong though, no. So looking at the triangles.
So the first one's wrong.
Root 3, in this case, because it's cosine, cosine is adjacent over hypotenuse. What side is adjacent to the root 3? Is it pi over 3 or is it pi over 6? Pi over 6. So that guy's a pi over 6. So this one is positive. Positive angle, quadrant 1. That's the O, okay? All right, and then over there, group 3 put up, where is tangent 1 over root 3? And it's positive. Well, first of all, they said, I would agree. It's one of those guys. It's gonna be positive. Tangent, where is opposite 1? Where is opposite 1? Pi over 6. So, half of you got half of these wrong. So, do you see the process?
I think that for the table, we should also label that these are for positive, negative.
Okay. All positive ratios, the angles are going to come from quadrant 1. And all negative cosine angles are going to come out of quadrant 2. All negative sine and tangent ratios, the angles are going to come from 4. And I want you to draw, like, is it one of these two or is it one of those two? And part of the point of it is some of you are going to want to go the long way around. You're going to want to, like, woo! No, that's too far. You're busting outside of that little semicircle. Okay, so we're gonna try the next batch. So, group 2, I would like you guys to write on the whiteboard behind you. And group 3 and 1, put your answers on the whiteboard. Group 5, if you could put your work over there. And 4, 6, and 7 on the little whiteboard. Group 9 up here.
Oh, yeah. This one's pi over 3 equals sine.
So which is why I have it around the board. It's easier to.
Is that the?
So it's.
What do you do?
One
Just,
hundred
this
thousand.
is like
Yeah,
basically.
this is father.
Oh.
Oh, okay, so we're, thank you.
And, yeah, yes. You guys are over here. Hang on, let me make the board clean for you. You just look at the pen, because I really, this is 7. Question, what was the question? Okay, so the sign, it is from one of those quadrants, it's negative, so it's down there, perfect. Now, sign is opposite over hypotenuse. So looking at the triangles, root 3 is opposite which angle? Cosine 1. I didn't mean for you to draw the triangle. Oriented the other way.
For this one, I got negative.
Well,
This one's
hang on,
pi
let's
over
use what we
3,
have.
you're getting,
So,
you're getting
root
closer,
3
right?
is right
So
here.
it's adjacent.
That is
over hypotenuse.
opposite which angle? The pi over 4th and the degree angle is pi over 2.
So that was pi
So
over- pi over
root
3.
3.
What was it trying to get at?
So let's say 1 over 0, so which angle?
I don't know, because that's.
0 over 1, 0.
Angle 2 over 3 across.
1 over 0 is outside.
Yeah,
0.
so the reference angle is going to be pi over 3.
Did you
So
guys
I
have
put that angle down
pi
here.
over 3? You guys get pi over 3.
Positive pi over 3 is up there, so what is this? Sure. Oh, yeah. Which means that.
Yeah, that's right, It has to.
So, when do we not use negatives for these ones?
I don't know how to do it.
I'm not sure if I'm right.
Because it has to go there. That's
But when
positive
do,
angle the whole way.
but when do we do, for like, if we have
Oh, wait.
Alright, alright,
four
let's.
sided
let's-
tangents, do we ever not use negatives? For like the 5 and the 5 over 11,
I think.
5 over 6?
Okay, alright, hold on. Okay, the negatives. So, group 3 and group 1 on the whiteboard, what do you guys have written for yours? So, cosine, okay, cosine is the windshield wipers, sunrise, I don't know what you wanna call it. It's a negative, so it's gonna go over there. And William, the short way around, the faster way to get there is this positive angle. So it's gonna be a positive. Alright, and cosine is adjacent over hypotenuse, so square root of 3 is adjacent to which angle? Pi over 6 or pi over 3? Pi over 6. So it's pi over 6, but these groups that did the work, they said, well, it's pi over 6, but it's over there. And it's pi minus, it's pi over 6 short. So it's 5 pi over 6.
Okay.
That takes you just 1/6 short of the answer, or of the.
So we would never use something like 11 pi over 6.
Okay, we're gonna get you guys good at this and then we're gonna change the rules.
Okay.
We're gonna make it lowercase for some solving problems. And when it's lowercase, all bets are off. Then I need to tell you something different.
Okay.
But the restrictions, I have to write on every single question, and I'm gonna forget one of them, and Ahmed's gonna be like, yo, you didn't tell us. Do you really, really want the infinite number of answers? And I'm gonna be like, oh god, no. Yeah, Lauren.
I just don't get how pi minus pi over 6 is 5 pi.
Okay. Do you agree half a circle is pi?
Yeah.
Minus 1/6. I need to do common denominator so that I can add them easily. I'm gonna multiply by 6 over 6.
Oh,
6 of these, take away 1 of these, don't I have 5 of these?
yeah. Oh, I get it now.
Okay, alright. Group 5, or problem 5 over there. So, sign being negative, both groups put this up. I agree. And that they're negatives down there. And I've been saying, okay, root 3, we want the root 3 is opposite the pi over to 3. But we wanted it down, so he made it negative. You guys get that? Like, sine and tangent are kind of the easy ones. If you can get the reference angle, just slap a negative on it. Okay, this guy, root 2 over 2, where is opposite 1 and hypotenuse root 2? They have written, not the restricted answer. Group 8 and group 10, and I see what you guys have on your board. Okay. They wrote down that one. You had to bust out of that little, like, restricted pink semicircle. You're not allowed to, like, when it's capitalized, it's restricted. You gotta stay inside that. If you're wanting to go all the way around, you're right that 7 pi over 4 does make sine negative root 2 over 2, but I wanted the restricted one from the calculator only. Is that making any sense? And this is the reason that I'm asking you to draw this first. You're stuck inside that little swoop
When it is big.
when it's capitalized, okay? All right. And just a heads up, not all of these are doable, and actually, like, some of the answers you're gonna get never. There are 4 nevers on there. But can you guys cross these off? Cross off 20, 21, 29, 31, 39, 41. You guys are like, yeah, happy to cross stuff off. Because even in honors, we don't ask them to know those. And there's 2 more to cross off. Nope, there aren't 2 more to cross off. So cross off those 6, you good? You get them all?
Yeah.
Can I go back to the problems yet? Yes, Ivan.
Does this, have we crossed off all the ones that are like not solvable?
These are not unsolvable, just where the answers come out of are different than, like, not worth arguing with you about. I did not cross off the ones that are not solvable. I want you to know that they're not solvable. So, we'll get there. All right. So group 3, I want you to put the answers to this one up, 1 and 2 on the small whiteboards. Group 6 here. Group 10 for this one. Yes.
Why can't you?
Because it's like you just, it's root 2 over 2 and you're gonna divide them and that gives you, like it's like, sine over cosine and they're both positive, so it's just.
Kind of.
So you want to be 1 over 4?
Do you guys get how to do this?
Or is it undefined? Maybe it's one of the big ones.
I'm struggling with these ones because
Positive, they all come out.
I don't know if it's supposed to be.
All right. Whoever put that one up there, I want the
I'm not
thing drawn.
fully sure which one we're looking at. Are we looking at the Y or the X? So we're looking at this one? Oh, this one.
Yeah.
So,
I know we're gonna go over them
That-
later, but I'm kind of confused. We're doing like, secant ones, like I know it's hypotenuse over adjacent, but like, is that sine over cosine, or is that?
Secant is 1 over cosine. Okay, all right.
in
Let's
that
see.
case, all of these would just be.
2 other groups still have to put theirs up. So,
I don't know how to do
group
it.
3, can you put yours up, or you did, okay?
Essentially,
Okay,
Or two.
it's not pi over 4
Or is
problem.
it pi?
Cosine is 0, then
Group 6, that's you got.
I use this, right?
One
Oh.
over the x values. One over negative
6, you guys have
one
this.
over 0, that's just.
Okay, let's look. Group 3 put up,
Oh, I get it.
still didn't tell me what art. Is it snow angels or is it windshield wipers? Snow angels, okay. And it's positive, so it's gonna be right there. Where is opposite over adjacent 1? It's like, it's not the right answer, what's your problem? Oh, no, you told me pi over 2, it's pi over 4. Oh, you did number 9, okay, sorry. That's what these guys are doing, okay. Or those guys over there. Okay, so sorry. This is what they did. These guys did sine, where is sine 1? Well, here's the stick. What angle is that? Pi over 2. And this one, okay, cosine. Cosine, is it snow angels or windshield wiper? Windshield wiper, okay. Where is cosine 1? Is it the x value or the y value? Your partner just saying. X. So what angle takes us there? 0.
Just 0?
Okay, and really want to get to this before the bell rings. Bella said, so this one, not digging the secant 0 thing, like something's up. To draw secant, Danny, secant is cosine or sine upside down? Cosine, okay, so there's cosine, vertical asymptotes, and the function of secant, those bubbles are gonna pop. And all this stuff goes away. When? This is -1, this is +1. When does the green swoopies hit 0? They don't. When is secant 0? It isn't. I have no answer. That is one of the 4 that's a. But I don't want you guys to go crazy with it because can tangent be 0? Tangent can be 0. Is tangent the snow angels or windshield wiper? Snow angels. Okay. And it's y, or yeah, y over x. When is the y value 0? Right there. So when is tangent 0? At 0. Okay. Cosine's the harder one. Angel cosine, is it this or is it this? The windshield wiper? Okay. Windshield wiper. Oliver cosine is the y value or the x value? X value. So when is the x value 0? Get it a little bit. Okay. The homework is to finish this sheet through page 33 minus the ones that I've crossed off.